Hi, my name is Nico, and today we're going to be discussing the operating principles of an opposed plunger injection pump on a diesel engine and how the fuel flows through the system. So, to begin, the fuel flows from the fuel tank through a series of fuel filters, first being the primary, to filter contaminants 25 micron and larger. It then proceeds to the lift pump where the fuel is pressurized to 3 to 5 psi, and from there, the fuel passes through the secondary fuel filter where further filtration of 5 micron and larger is cleaned. In the case where the fuel tank is above the injection pump inlet, a lift pump may not be required for that specific setup. From the secondary fuel filter, the diesel then enters the vane type transfer pump, which is located here on the opposed plunger unit. As the rotor speed increases, so does the volume and pressure of the fuel. The fuel from the transfer pump forces the regulating piston against the spring-controlled discharge pressure of 26 psi during starting and 40 psi at idle. Excess fuel from the increased RPM flows through the regulating slot back to the inlet side of the transfer pump. The maximum pressure is 90 to 120 psi at high idle. So the piston you can't see, but it's here, and the excess fuel that'll be created will flow back to the inlet side of the pump. From there, the fuel flows through passages to the metering valve, which is located here. Hydraulic timing advance mechanism, down here. And to the pump housing, which is used to regulate return pressure to about 4 psi and is also used to deaerate. So the fuel will flow through this orifice with the wire in between it to help deaerate. And once the pressure exceeds 4 psi, this valve will open and the fuel will return to the tank. The metering valve is influenced by the operator's demands, but primarily controlled by the mechanical governor. So the metering valve will rotate, and it's connected to this rod, which will be controlled by the operator's demands and the governor through the spring. The governor is able to control the amount of fuel through the metering valve based on engine speed and load. Its ability to do this is through the flyweights, which are located here. As the engine speed increases, the weight comes outwards because of the centrifugal force. This increases tension on the spring, decreasing the amount of fuel through the metering valve. So it'll put pressure on this spring, and this will rotate the metering valve to a less fueling position. It'll be the opposite for lower engine speeds. This adjusts the amount of fuel delivered to the rotor fuel inlet, right here, and the pumping chamber by the annular groove. So the annular groove is located here. You can't see in this picture. That's the bottom part of it here. Don't be confused with the red pencil here. As the pressure of the transfer pump increases, it pushes the hydraulic advance piston, causing the cam ring to rotate in the opposite direction of the rotor. So the piston down here will cause this to rotate in the opposite direction that the rotor is spinning. That will increase the advanced injection timing. Rotation of the metering valve increases or decreases fuel. From the metering valve, the fuel is allowed to enter the rotor charging port, located here, with a clearance of 1 to 3 micron in between the rotor and the pump housing. It forces the opposed plungers apart. The rotation of the cam ring squeezes the plungers together, pressurizing the fuel down the center orifice of the rotor. So the fuel will be compressed by these two plungers right here and forced down here. It won't be allowed to enter back into the pump housing due to misalignment of the ports here. The fuel now has to overcome the delivery valve pressure, which is 3 to 500 psi. So 3 to 500 psi is required to press this piston down here, allowing the fuel to travel further. The outlet port in the rotor to the injector nozzle port. So located right here, same with the 1 to 3 micron gap. It will then flow through the equal length heavy wall seamless steel tubing to the injector, causing the combustion process. Thank you for your time.